National Electrical Code Section 220.14 defines the maximum branch circuit load as 80% of the circuit rating. For a standard 120 volts, 20 amps branch circuit, this equates to a maximum load of 16 amps, which is 80% multiplied by 20 amps. Typical computer, monitor, printer, scanner, and radio combined load is around 2.5 to 3.5 amps. Momentary load spikes can occur during startup or operation and could be around 5 to 8 amps. To account for potential future increases in load, it is recommended to use a safety factor of 1.25. A branch circuit rating is 16 amps, for example, a 20 amp circuit with 80% load limit. A computer circuit is 10 amps, which is 2.5 amps average load times a 1.25 safety factor. Two computers with peripherals 2 times 10 amps, which equals 20 amps, can be safely fed from a single 20 amps branch circuit. For more than 2 computers, additional branch circuits may be required. Conduct a load calculation based on the actual equipment used in the office. Use an ammeter to verify the actual current draw under typical operating conditions. Monitor the load periodically to ensure that it remains within the specified limits. Some high-performance computers or specialized equipment may have higher power requirements. Consider the potential for future upgrades or additions to the office equipment. Consult with a qualified electrician for specific design and installation guidance. This guideline is intended to provide a reasonable estimate of computer loads and branch circuit capacity in office environments. Always consult the applicable electrical code and local regulations for mandatory requirements. When calculating computer loads in an office environment, there are several key considerations to ensure safety and code compliance. Firstly, it is essential to understand the guidelines provided by the National Electrical Code, or NEC. Section 220.14 of the NEC specifies that the maximum branch circuit load should not exceed 80% of the circuit's rating. This means that for a standard 120 volts, 20 amps branch circuit, the maximum allowable load is 16 amps. Secondly, determine the actual power consumption of the computer and its peripherals. A typical setup, including a computer, monitor, printer, scanner, and radio, usually draws between 2.5 and 3.5 amps under normal operating conditions. However, it's important to account for peak loads, which can occur during startup or when the equipment is performing intensive tasks. These peak loads can range from 5 to 8 amps momentarily. Thirdly, incorporate a safety factor to accommodate potential future increases in load. It's recommended to use a safety factor of 1.25, which means multiplying the average load by 1.25 to determine the appropriate amperage rating for the computer circuit. For example, if the average load is 2.5 amps, the recommended amperage rating would be 3.125 amps, or rounded up to 3.2 amps. Fourthly, calculate the branch circuit capacity to determine how many computers can be safely connected to a single circuit. Given that a 20 amps circuit with an 80% load limit can handle 16 amps, and each computer with peripherals requires approximately 10 amps, 2.5 amps average load times 1.25 safety factor, 2 computers can be safely powered by one 20 amps branch circuit. If more than 2 computers are needed, additional branch circuits should be installed. Fifthly, verify your calculations by conducting a load calculation based on the actual equipment used in the office. Use an ammeter to measure the current draw under typical operating conditions and monitor the load periodically to ensure it remains within the specified limits. In addition to these general guidelines, there are some additional considerations to keep in mind. Firstly, high-performance computers or specialized equipment may have higher power requirements, so it's important to factor that into your calculations. Secondly, consider the potential for future upgrades or additions to the office equipment, which may increase the overall load. Finally, always consult with a qualified electrician for specific design and installation guidance to ensure compliance with all applicable electrical codes and local regulations. These guidelines are intended to provide a reasonable estimate of computer loads and branch circuit capacity in office environments, but they should not be considered a substitute for professional advice. Always prioritize safety and adhere to all applicable codes and regulations when designing and installing electrical systems. To summarize, firstly, adhere to the NEC guidelines, specifically Section 220.14a, which limits branch circuit loads to 80% of the circuit rating. Secondly, determine the actual power consumption of the computer and its peripherals, considering both average and peak loads. Thirdly, incorporate a safety factor of 1.25 to account for potential future increases in load. Fourthly, calculate the branch circuit capacity to ensure that the number of computers connected to a single circuit does not exceed the allowable load. Fifthly, verify your calculations using an ammeter to measure the actual current draw and monitor the load periodically. Sixthly, consider any additional factors, such as high-performance computers or potential future upgrades, that may affect the overall load. Finally, always consult with a qualified electrician for specific design and installation guidance and to ensure compliance with all applicable codes and regulations. By following these guidelines, you can ensure that your office environment is safe, efficient, and compliant with all electrical codes and regulations. The NEC provides essential guidelines for electrical installations, and it's important to adhere to these guidelines to ensure the safety of personnel and equipment. In the context of computer loads in office environments, several sections of the NEC are particularly relevant. Firstly, Section 220.14 specifies the maximum branch circuit load, as mentioned earlier. Secondly, Section 210.21 addresses the use of overcurrent protection devices, such as circuit breakers and fuses, to protect branch circuits from overload. These devices should be properly sized to match the ampacity of the circuit conductors and the connected loads. Thirdly, Section 210.23 outlines the permissible loads for branch circuits, depending on their ampacity and the type of loads they serve. This section provides guidance on how to distribute loads among multiple branch circuits to prevent overloading. Fourthly, Section 250 covers grounding and bonding requirements, which are essential for preventing electrical shock hazards and ensuring proper equipment operation. All computer equipment and electrical outlets should be properly grounded to provide a safe path for fault currents. Fifthly, Section 300 contains general requirements for wiring methods, including the types of conductors, raceways, and boxes that are permitted for use in different applications. This section also addresses issues such as conductor dirting, which may be necessary when multiple conductors are installed in close proximity to each other. In addition to these specific sections, it's important to be familiar with the NEC as a whole and to stay up to date with any revisions or amendments that may be issued. The NEC is a comprehensive document that covers a wide range of electrical topics, and it's essential to have a thorough understanding of its provisions to ensure safe and compliant electrical installations. Remember that the NEC is not a substitute for professional engineering judgment. It's always best to consult with a qualified electrical engineer or electrician to design and install electrical systems that meet your specific needs and comply with all applicable codes and regulations. They can assess the unique characteristics of your office environment, such as the types of equipment being used, the layout of the space, and the local electrical codes, and develop a customized solution that ensures safety, efficiency, and reliability. Furthermore, it's important to document all electrical installations and keep accurate records of the equipment used, the circuit configurations, and the load calculations. This documentation will be helpful for future maintenance, troubleshooting, and upgrades. It will also be essential for demonstrating compliance with the electrical codes and regulations to inspectors and other authorities. In summary, the NEC provides essential guidelines for electrical installations in office environments, including requirements for branch circuit loads, overcurrent protection, grounding, and wiring methods. It's important to be familiar with these guidelines and to consult with a qualified electrical engineer or electrician to ensure that your electrical systems are safe, efficient, and compliant with all applicable codes and regulations. Accurate documentation of electrical installations is also crucial for future maintenance and compliance purposes. When conducting load calculations for computer equipment in an office environment, it's important to consider the potential for future expansion or upgrades. The electrical system should be designed with sufficient capacity to accommodate anticipated increases in load to avoid the need for costly and disruptive modifications in the future. There are several strategies that can be used to plan for future expansion. Firstly, oversized branch circuits can be installed to provide additional capacity for future loads. For example, a 20 amp circuit can be used to power a single computer workstation, even if the current load is only 10 amps. This will allow additional equipment to be added to the circuit in the future without exceeding the 80% load limit. Secondly, spare conduits and raceways can be installed to provide pathways for future wiring. This will make it easier to add new circuits or upgrade existing ones without having to tear into walls or ceilings. Thirdly, a flexible electrical distribution system can be used to allow for easy reconfiguration of circuits and loads. This may involve the use of modular power distribution units, or PDUs, that can be easily reconfigured to meet changing needs. Fourthly, the electrical system can be designed to accommodate future installation of energy-efficient equipment. This may involve the use of higher voltage circuits or more efficient lighting and HVAC systems. By planning for future expansion and upgrades, you can ensure that your electrical system remains adequate and efficient for years to come. This will save you time and money in the long run, and it will help to avoid disruptions to your business operations. Remember that it's always best to consult with a qualified electrical engineer or electrician to develop a comprehensive plan for future expansion. They can assess your specific needs and develop a customized solution that meets your requirements and complies with all applicable codes and regulations. In addition to planning for future expansion, it's also important to consider the impact of computer equipment on the overall energy consumption of your office. Computer equipment can be a significant source of energy consumption, especially if it is not properly managed. There are several steps that can be taken to reduce the energy consumption of computer equipment. Firstly, use energy-efficient computers and monitors. Look for equipment that is Energy Star certified, as this indicates that it meets certain energy efficiency standards. Secondly, enable power management features on computers and monitors. These features will automatically put the equipment into a low power state when it is not in use. Thirdly, turn off computers and monitors when they are not in use. This may seem obvious, but it is often overlooked. Fourthly, use power strips to turn off multiple devices at once. This will make it easier to turn off all of your computer equipment at the end of the day. Fifthly, consider using thin client computers. Thin client computers are designed to run applications from a central server, which reduces the processing power and energy consumption required at the desktop. Sixthly, educate employees about energy conservation practices. Make sure that employees understand the importance of turning off equipment when it is not in use and using energy-efficient settings. By taking these steps, you can significantly reduce the energy consumption of your computer equipment and save money on your electricity bills. This will also help to reduce your carbon footprint and contribute to a more sustainable environment. Remember that energy efficiency is not just good for the environment, it's also good for your bottom line. By reducing your energy consumption, you can lower your operating costs and improve your profitability. Furthermore, it's important to regularly monitor your energy consumption to identify areas where you can further reduce your usage. This can be done by installing energy monitoring equipment or by reviewing your utility bills on a regular basis. In conclusion, planning for future expansion and managing energy consumption are both important considerations when designing electrical systems for computer equipment in office environments. By taking these factors into account, you can ensure that your electrical systems are adequate, efficient, and sustainable for years to come. Always consult with a qualified electrical engineer or electrician to develop a comprehensive plan that meets your specific needs and complies with all applicable codes and regulations. Computer rooms and data centers have specialized electrical requirements due to the high density of electronic equipment and the need for reliable power. These environments typically require redundant power systems, backup generators, and uninterruptible power supplies, or UPS, to ensure that critical equipment remains operational even during power outages. The electrical design of a computer room or data center should also take into account the need for proper grounding and bonding to prevent electrical noise and interference, which can disrupt the operation of sensitive electronic equipment. Furthermore, it's important to provide adequate cooling to prevent overheating of the equipment. This may involve the use of specialized cooling systems such as computer room air conditioners or crack units or liquid cooling systems. The electrical system should be designed to support the cooling requirements of the equipment, including the power consumption of the cooling systems themselves. In addition to these technical considerations, it's also important to comply with all applicable codes and regulations. Computer rooms and data centers may be subject to stricter electrical codes than typical office environments, due to the increased risk of fire and electrical hazards. It's essential to consult with a qualified electrical engineer or electrician who is familiar with the specific requirements for computer rooms and data centers. They can help you to design and install an electrical system that is safe, reliable, and compliant with all applicable codes and regulations. Furthermore, it's important to conduct regular inspections and maintenance of the electrical system to ensure that it remains in good working order. This may involve testing the backup power systems, inspecting the grounding and bonding connections, and cleaning the cooling systems. Regular maintenance will help to prevent equipment failures and ensure that the computer room or data center remains operational at all times. In summary, computer rooms and data centers have specialized electrical requirements due to the high density of electronic equipment and the need for reliable power. These environments typically require redundant power systems, backup generators, UPS units, proper grounding and bonding, and adequate cooling. It's essential to comply with all applicable codes and regulations and to conduct regular inspections and maintenance of the electrical system. Always consult with a qualified electrical engineer or electrician who is familiar with the specific requirements for computer rooms and data centers. The trend towards remote work and distributed offices has created new challenges for electrical design. With more employees working from home or in smaller satellite offices, it's important to ensure that these remote locations have adequate electrical capacity and safety features. Home offices, in particular, may not be designed to handle the electrical loads of modern computer equipment. It's important to assess the electrical capacity of the home office and to make sure that it is adequate for the equipment being used. This may involve adding new circuits or upgrading existing ones. Furthermore, it's important to install surge protection devices to protect sensitive electronic equipment from power surges. Power surges can occur due to lightning strikes, utility switching, or other electrical disturbances. Surge protection devices can help to prevent damage to computer equipment and other electronic devices. In addition to these technical considerations, it's also important to address ergonomic issues in remote work environments. This may involve providing employees with adjustable desks, chairs, and monitors to prevent strain and discomfort. It's also important to ensure that the lighting is adequate and that the workspace is free from distractions. By addressing both the technical and ergonomic aspects of remote work environments, you can create a productive and comfortable workspace for your employees. This will help to improve employee morale and productivity and reduce the risk of workplace injuries. Remember that remote work is not just a temporary trend, it is likely to become a permanent part of the modern workplace. It's important to invest in the infrastructure and support systems needed to make remote work successful. This includes providing employees with the right equipment, tools, and resources, as well as ensuring that their remote work environments are safe, comfortable, and productive. In conclusion, remote work and distributed offices have created new challenges for electrical design. It's important to assess the electrical capacity of remote locations, install surge protection devices, and address ergonomic issues. By taking these steps, you can create a productive and comfortable workspace for your employees, wherever they may be located. Always consult with a qualified electrical engineer or electrician to ensure that your remote work environments are safe, efficient, and compliant with all applicable codes and regulations.